My name is Dustin Potter. I am one of the solutions architects here at EagleDream Technologies. And today we're really just going to be talking about getting the most out of your actual cloud transformation. So one of the questions in the poll box that you guys just saw pop up is, have you worked in a data center? Make sure that we get that out of the way. We'll give everybody a second to really respond to that.
Yeah, I'm seeing folks are taking the poll now, Dustin. Thanks everybody for participating. I'll leave it up for just a couple seconds. Interesting responses here. Love it. All righty. Ready to take a look, Dustin?
Yeah. All right. Wow. So we actually have, a fair amount, 6 out of the 11, 55% that actually haven't, and we have 45% that actually have. So that's good. It's a lot more than I've seen other places. Well, hopefully for those of you that have, your data center did not look like the picture shown on the screen here. That would be god awful and atrocious. But when I graduated, I actually didn't work in a data center, unfortunately. I would have loved to. I think that it would have been a really great experience. I graduated as a software engineer and I started working at a telecom company that owned and operated data centers. So we ran our own workloads in it. We ran customer workloads in it. So I was very accustomed to working kind of in that on-premise world. And at the time, I joined part of like the web application team. We ran portals, web services, internal tools and utilities. We used a lot of the kind of common enterprise technologies at the time. We were running J2EE. We were using a combination of JBoss and Tomcat. And of course, because it was an enterprise, there was an AS400 sitting around somewhere. I don't really know where. But I remember that when I graduated, I wasn't really aware of the concept of interdepartment budgets. I had written an internal application at the time. I just finished it and I needed to get it hosted somewhere. I just needed a VM. So I went to my manager and I asked her what the next steps were. How do I get this deployed? And she looked at me and she goes, well, it's going to take us a month for the infrastructure department to provision us one, and we don't really have it in the budget. And I was floored. I couldn't believe it because, we own these data centers. How are you telling me that I can't get a virtual machine? I'm not asking for more hardware. I just want a VM. But that was the reality. So I moved on. We hosted it on some existing virtual machine that had another application on it. It made it more constrained, put more load on the system, all the things that I didn't want to do, but, that was life. So fast forward a little bit, and I'm working at EagleDream Technologies. So, a lot of us at EagleDream had worked at the telecom that I was just talking about. We've been running data centers for 10 years, and we really didn't want to be in that business anymore. We wanted to focus more on the application development. So AWS was a logical choice for us. And I joined and we started writing this healthcare analytics application. And of course, we used AWS. And even though it was wildly different, from what it is now to write a HIPAA-based application in AWS, just because the amount of services back then that were HIPAA certified were very little compared to what they are now. So you kind of had to write it a little bit as if you were in a data center. But even then, it felt tremendously different. Like, this is how I really envisioned the data center was supposed to feel like. So fast forward again to today, and my job title has changed a little bit. I no longer do software development. I focus much more on cloud architecture. I help others do cloud native app dev. I help companies migrate to the cloud, figure out what they're doing, how they can go about their transformation. I do a lot of what's called well-architected reviews, which is where I'll sit down with a customer and we'll look at an existing workload on AWS. It's like a 3 to 5 hour conversation where we kind of dive into the individual aspects, things from as small as how you're using version control and how you're pushing out changes to how are you architecting your AWS accounts. And in general, I just try to do a lot of education and advocacy for cloud technologies. So the title of this presentation is Getting the Most Out of Your Cloud Transformation. And what does that actually mean? Well, the key word here is most. So, a lot of people in this chat are really, in the middle of a cloud transformation or thinking about going through a cloud transformation. And how do we make sure that we're really getting our biggest bang for our buck? We can tackle that issue kind of head on. Right? We can take that issue of cost. We can make sure that we're right sizing instances, that we're not over provisioning things. We can make sure that we're using the right pricing models. Instead of on demand, we can use something called reserve pricing. We can tackle scaling because this is really easy in the cloud now. But these are all kind of things that I talk a lot about in the well-architected reviews that I mentioned. And they're very important, they're necessary, and they're conversations that we absolutely need to have. But because I talk about them all the time, I really don't want to talk about them here. I want to talk about these three things that I don't get to talk about as much, which is application modernization. It's data lakes, which is a new concept that has kind of came up more recently. And finally, artificial intelligence and machine learning, stuff that I just don't get to talk about as much as I'd like day to day. So we'll start with application modernization. So first off, what is that? It's modernizing an application. Obviously that's a little tautological, but really when I think about application modernization, I think about bringing that piece of software closer to what we would call cloud native. And cloud native is this term that we've started using in the past few years. It really reflects how you write your application software in relation to your infrastructure. Back in the day at the data center, we used to write our software so it was agnostic of the underlying infrastructure. And to some extent, it's still true today, right? For example, if I've got a node server, I don't care if it's running on Windows or CentOS or Red Hat or any other operating system. However, what's different about the cloud compared to the data center is that everything is an API call now. I can create and destroy infrastructure from within my application because I've got this nice little integration point. And that's immensely powerful to me because now I'm much closer to the source and I can take action a lot faster, much faster sometimes than what I could have done with some sort of external observability. And I can start tackling things that are troubling the system in entirely different ways. I can look at resiliency and reliability differently now. If I detect an issue, I can detect it closer to the source. If I detect a failure, I can kill off infrastructure that's no longer functioning as I intended to. I can look at performance. If I've got a KPI, a key performance indicator that I'm measuring, and I want to kind of keep it at a certain point, I can scale to do that, and I can scale very quickly. I can start using other services that would allow me to offload some of the processing power, like queues or dedicated stream processors. And then, finally, there's cost, which is typically tied closely to performance. Any resources that I'm creating to maintain those KPIs for performance reasons can be deprovisioned as soon as I'm done with them. So I only pay for what I need, and I only pay for how long that I actually need it. But when we talk about application modernization, we're often talking about doing this in the context of a migration. We've got an application that has already been written, it's operating somewhere in a data center, and I want to bring that to the cloud, and in doing so, I want to modernize it in some aspect. So for the purpose of this presentation, we'll break this down into three main steps, or three main options that we have to go about doing this. So first off is lift and shift, which is usually the first place that organizations start. This is going to be speccing out servers. It's going to be making sure that I've got the right CPU and memory, taking what I've got on premise and matching that as close as I can in the cloud. I'm going to be probably mimicking my architecture from what I have in the data center as well. And that's, it's good, it's okay, it's a good place to start. But the problem with this is that if all I do is mimic and use the cloud as a data center, then I'm not going to see a lot of gain. I'm not going to see a lot of cost savings. On the plus side, at least I'm in the cloud, and this gives me the speed and the agility that the cloud providers offer. The next step that we typically look at is replatforming. This is where you might target a few different spots in the system to upgrade. This is what I like to call lift and shift plus, kind of as if I'm waiting to get my car washed and I'm looking at the board that shows all my options, and each one kind of builds on the last. And this is lift and shift plus, where I'm going to take what I've already got, migrate it to the cloud, and then start looking at a few different things. Maybe I'm running on Microsoft. Microsoft is very expensive in the cloud, mainly because of licensing fees. And maybe I don't really want to re-architect my project. I don't want to use a different language, but I don't want to run on Windows anymore. So maybe I start looking at .NET Core. That way I can run on Linux instead. Or maybe I start looking at something like RDS, which is AWS's database as a service. That way I can offload the management of my database. So you see all those little ways that we can kind of pinpoint parts of our application to upgrade. So then finally, I have re-architecting, which is kind of like this gold standard. This is what we would all love to do. This is where everything is up to be changed. I can use different languages. I can use different frameworks. I can use different database technologies. I can change entire communication paths throughout my system. Maybe I had some queuing mechanisms in there to offload batch processing. This is where I really start to think of the cloud as more of a holistic platform instead of a data center, because it's not. It's so much more than just a data center. And you'll see that as you go left to right on this, you start to see your savings go up and you drive your TCO, your total cost of ownership, down. And because now I'm not managing nearly as much, I get closer. I get closer to this idea of serverless, where I don't even have to worry about spinning up the server and making sure it's patched. I just run it. I write an application and I tell the cloud to run it. So then, the next thing that we really talk about in application modernization is databases. And this is a question that we get asked all the time. Everyone ends up asking this question, right? Which database is better? The problem with this question, though, is that there isn't an answer. This is something where typically we've got one of the biggest design decisions of the application software. And conversely, it's going to be one of the biggest constraints in the system. But a lot of us have probably been in the scenario where for some reason the application was failing because the database was failing. Even if I've architected my system in a way where my web servers scale out, I've still got that single point of failure, which is the database. And if that gets overloaded, then I'm kind of SOL. We really need to look at the databases and have a conversation around it because it's such a key point in the application design. And the database used to be thought as the Swiss Army knife of our application development. I could do everything in the database if I wanted to. I had constructs like PL SQL. I had procedures. I had job pipelines and queues. I could even make HTTP calls, which is a really strange thing for a database to be able to do. And we don't want to think about it like that anymore. The old adage of when all you have is a hammer, everything looks like a nail definitely applies here. If I've always been using the same database technology and I'm faced with a new problem, I'm going to use that database to solve that problem, even though that might not be the best tool for the job. And when you think about it, when we're making something tangible, say we're doing woodworking or something like that, we don't use a single tool. We use 20, we use 30 different tools to accomplish that job. And we need to start thinking of application design and databases in particular, in that same way. We have different databases that do different things, and they're made for specific workloads, and we need to start identifying those workloads. So instead of asking which database is better, we need to be asking this question instead: what is our use case? Because based on our use case, we're going to use a different database. So we're going to divert slightly for a minute, just because we need to make sure that we understand something when we talk about databases and application design. We need to talk about vertical versus horizontal scaling. So in the data center, we usually talk about vertical scaling. My system isn't fast enough. Okay, well, let's just make the system bigger. Maybe I have to migrate to new hardware, something that has more CPU and more memory. But this really only gets us so far because there's a limit to which we can scale like this. And typically, this ends up being very costly, tremendously costly, especially when you get into very, very large servers. So instead, we need to be thinking of horizontal scaling, which is where I'm going to add more servers. I'm going to distribute that load. This is really nice because it's fast and I can use a lot of small servers. And then I can deprovision, I can provision based on the load of my system. So coming back from our detour just a second, we want to talk about what the use case is, and that determines based on what our database purpose is. So the first one on this list you'll see is document stores. These are going to be meant for OLTP, and OLTP, for anybody not aware, is online transaction processing. OLAP, conversely, is online analytics processing. So OLTP is what you're really going to think of when you're serving web service requests and offering up APIs. You need millisecond latency. You want the responses to be immediate. This is where the environment where you're going to want to start using the document stores, things like DocumentDB, DynamoDB from AWS, Cassandra's out there. But then you have the relational databases, right? The Postgres's, the MySQL, the SQL servers of the world. These are going to be our go-to for OLAP workloads like reporting and analytics. And yes, you can do OLTP with these. We've been doing this for years and it worked pretty well. But it doesn't scale, especially when you get to what people talk about nowadays as internet scale. These are just going to end up falling down. But then below that, we have the data warehouses, and that's marked as OLAP2. So we have to talk about what is the difference here. It really comes down to a matter of scale and how the database itself is architected. We talked about horizontal scaling on the previous slide. Technologies like AWS Redshift utilize that along with a distributed architecture to provide true data warehousing scale and capability. And then finally, you'll see we've got this data lake thing, right? And we've declared, we haven't really declared what the use case is here yet. And that's because it's relatively new and a lot of people haven't heard of it. So they're just not sure why we need to start using this. So what is a data lake? As you can see on the screen, a data lake is a centralized repository for all the data in your organization. It could be structured data, it could be unstructured data, it could be any file format or type, it could be JSON data, it could be CSV data, it could be flat files or files that are gzip or compressed with Snappy. It doesn't matter. You can store any of it, right? But that doesn't really answer the question for us very well. It didn't, at least for me years ago, because even back when I was doing a lot of data warehousing, I was still very in tune with what was going on in the AWS ecosystem. And when the idea of a data lake came out, I still didn't understand it. I was used to my little world in the data warehousing world, and this didn't really fit it. I looked at it and I thought, well, that sounds kind of like a data warehouse, so why would I change what I'm doing? So to help answer that, this is more of a visual representation of data lake. And don't worry, I'm not going to walk through every single one of these services. That would be awful for everybody on this call. But I want to use it to illustrate that when we think of a data lake in AWS, we think of S3 as kind of the center of our universe. We use that to store any type of data in the cheapest way possible. And then we utilize a suite of tools to work with that data. And in the end, we have this concept of a data lake. And that is truly what a data lake is. It's a concept using an array of tools. It's not itself just a product. And on this, you can see that we group those tools together. For example, you can see on the left, we have data ingestion, ways to get data into our data lake. This is obviously very important. We have catalog and search at the top, which is ways for indexing our data and knowing what all data that we have. This is important when we're dealing with an object store like S3. It can be really hard to track everything. Without that tracking, you can end up with what we call a data swamp. And then on the right here, you can see that there's tools for analytics and searching. This is where we start to utilize other purpose-built databases to accomplish a specific task. Remember, we always want to use the right tool for the job. And one of the key benefits of having the data lake is that we can really unsilo all of our data. Most applications have their own databases, which is good because it allows the database to be designed for that application. But it then becomes difficult to really gain insights across multiple data sets that I have in multiple databases. But by replicating this data to a data lake, we can then do the analysis across databases and data sets, giving us that higher level view of the organization's operations. And so one thing that we always have to do, though, is ask the question of whether or not it's useful in the real world. It's fun to talk about all these topics and these ideas, but is this something that's actually useful right now? So we've got Transcat, and Transcat's business is measurement devices as well as like the calibration of them. They had a problem that a lot of other businesses share. They had about 7 or 8 databases that all held different data. They had tech data, they had calibration data, they had invoicing data, they had sales data, all important things, but they couldn't query across it. They had no idea what was going on at the higher level. And always make sure to use the right tool for the job. And the data lake is really perfect here. We worked with them to set up the data lake. We set up the jobs to get the data into it. We set up the ETL to transform things into the formats that are more useful for us. We ended up using AWS QuickSight, which is a BI tool that AWS offers if anybody's more familiar with like Power BI or something like that. It's very similar. All this without impacting their underlying databases and applications. And that's really what we want to be able to do. We want to be able to function as we are and keep going about our normal day-to-day while getting these higher level insights. Now, another advantage of having a data lake in a vast store of different data is we've accidentally kind of created a great environment for AI and ML. So artificial intelligence and machine learning, it's kind of been all the hype recently. There's a lot of people touting how awesome it is. There are people out there that are writing books by feeding AI data based on books by a particular author. And sometimes they're really funny and maybe a little bit hard to read, but it's entertaining. But that type of thing doesn't really help me as a business, though. The whole realm, used to be something that required a PhD. It was an academic problem. This wasn't something that a lot of the engineers were talking about. In our pragmatic and practical world, we didn't really care about AI and ML. And I do think that a lot of people tend to utilize these concepts for things that don't necessarily require them. For example, there are a lot of analytics being done via machine learning that I could probably do with a standard SQL query. But there are some other interesting opportunities that we haven't looked at yet. So how can I actually use AI and ML to get the most out of my cloud transformation? So we have these high-level services. And all of these AWS services, I can integrate in my software via an API call. And this has, this made it transfer from an academic problem to just a software problem. And I can still go beyond these if I want to. If I want to build my own model for a very unique job, I can still do that. But we found that a lot of businesses have the same use cases. So why not create a higher level service for that? And this is a small subset of the services that are offered by AWS, and I won't even walk through all of them. But to just give a little taste, we have Poly, right? Poly is just text to speech. Very simple, but also very useful. I don't need to package anything in my application. I don't need to make sure that my dependencies play well with its dependencies. It's just an API call. I send it text, it sends me back an audio file. Perfect. We have Forecast, and Forecast is actually something that came out of Amazon.com. Because if there's any company that needs the ability to forecast, it's Amazon.com. They built it, it worked really well, but they turned around and they figured that everybody else could use it too, so why not? And then you've got like recognition, which is one of my favorites. It's just image recognition, plain and simple. And I always think of this as kind of the poster child for AI and ML. Recognition allows you to train a model to identify really anything. It could be an object, it could be a face, it could be anything that you want, and again, it's just an API call. But just like the data lake, we have to be sure to ask the question, is this actually useful in the real world? So we can walk through that a little bit. So we've got virtual moving technologies, and the guys behind VMT had this really novel idea where they wanted to eliminate the need to go on site to get measurements when estimating a moving job. So instead, they had this idea where you could take pictures of your apartment or your house, and you could send it to them so that they could give you a quote. And they were doing this by having people actually review it. They found that by doing this, their quotes were about 75% accurate to what the actual cost of moving was. And they looked at this, and thought this is a prime use case for recognition. So they ended up working with us to build it out, and it ended up being pretty easy. Now the pictures that you take of your house get fed to recognition. And recognition turns around and says, oh yeah, there's a chair, there's a sofa, there's an end table. It also has to know what's not movable. For example, I'm not going to be moving a window. But the quote that they were able to generate now is about 85% accurate. They don't need to waste people's time having them look through a bunch of pictures. So great use of the technology. So we actually created this a while back for another tech talk. We use RingCentral as our communication platform, as you can see by using it right now. And a few years ago, we started using Alexa for Business. And so now we've got this kind of Alexa device sitting in each one of the conference rooms. I can walk in and I can say like, hey, Alexa, start my meeting. It's useful and it works and it's fine. But we thought that it would actually be a lot cooler if we could just start the meeting via facial recognition alone. So instead, we decided to do like a proof of concept, right? We took a deep lens camera, which is basically a Linux box with a camera attached. You can see it in the picture on the right side, and wired it up to AWS recognition, which we had trained to identify some of us here at EagleDream Technologies and integrated that with the Alexa device. The best part about this, though, is it took us like 6 hours. It was only a proof of concept, but it was only 6 hours of our time, all because we've got the availability of some of these new and cool services. So we've got all these new ways to transform the cloud that we didn't have 5 to 10 years ago. These are the things that are going to help us get the most out of it. So we really have to look back and review like what we had then versus what we have now. Back in the day of the data center, I had agnostic software, right? I didn't care about the infrastructure, what it was running on. I didn't know what it was. I couldn't know what it was most of the time. But now I can have infrastructure aware software. I can control that infrastructure, and I can create and I can destroy it. Before we had these siloed databases that were good for the applications, but not good for our higher level business level analytics. But now, I've got this concept of a data lake that lets me have the best of both worlds. Keep the database purpose built, but let me query and analyze across my different data sets that I have. Before, we always thought of AI and ML as a problem for the academics. But now we've kind of moved into this world where we've got these higher level services that allow us to string together these really useful features with very little effort. So finally, before we had the physical data center and all the constraints that came with it. But now our data center is an API, and we can shape it to optimize for our applications. So our landscape has changed, and there's just so many more tools now at our disposal to help create truly impactful systems. So I really just want everybody to think about on this call, the transformation that you're going through right now. Do you think that you're getting the most out of it? Thank you.
Awesome. Thank you so much, Dustin. That was great. I got some really good audience questions for you.
Great.
So David, thank you so much for tuning in with the Q&A box. The first one, loved this as well. He loved how you boiled down cloud native to essentially an API call. Could you expand a little bit more on that?
Say the question again.
David loved how you boiled down cloud native to essentially an API call. Could you talk about that a little bit more?
Yeah, I mean, now, just as a lot of people are used to, going into some sort of console, whether it's the AWS console or Azure or whatever, they still think of things as, point and click, and under the hood, it's really just an API, and we have access to all of that from an application level. And it takes a little bit of a mindset change to think about that, but realize that the data center that I'm now running in is part of my application. I can control every aspect of it. I can create alarms and alerts and different metrics on the fly based on what I'm seeing. So as I'm interpreting things and as my application is running, I can adapt and I can set up new infrastructure that might not even be there to help me scale, but just help me make the system perform better because I understand what's going on, and it's all just an API. It's all as if it's part of my application, and it's awesome. It also makes writing applications a lot funner.
True, very true. And then another question, follow up to that, is even with all the benefits of migrating to a fully cloud native environment, what is the top or the top two roadblocks for enterprises migrating to the cloud today? Is it too much work, lost weekends? This is another great question from David.
Yeah, I mean, it's education. I mean, it's a whole different world, and we have these experts that are still building applications in the data center, and they've got all this knowledge, but it's a different knowledge set, and so it just takes time to learn all these new tools. A lot of this stuff is actually pretty much the same as it was 20 years ago. It's just it's a little bit better. There's different terminology. It's wrapped in APIs now. So it's not that you've got to relearn an entire industry, but your mindset around it has to change, and that obviously takes a lot of time. Then also, you've always got the problem of getting the buy-in from the higher level business owners to do that migration or take the time to do that re-architecting as opposed to just the lift and shift.
Awesome. And then another question from Michael, following up from the first one. Can you talk about how you secure APIs?
So if you're talking about, there's two ways to answer that question. And it depends on if you're trying to secure your own APIs or if you're dealing with these cloud providers' APIs. So, in the case of the first one, you've got a number of different options, right? You could go as simple as just a token based, right? I could issue a client ID. Not terribly secure, but if it's a more public API and you just need it to identify a person, sure, it might work. But then you can use other tools. You can use OAuth, you can use JWTs, especially if you've kind of got a distributed authentication system where you might need to issue the token that basically tells what the bearer is allowed to do. But if you're talking about and there's also a lot of tools in AWS that allow you to do that too. If I want to write APIs, I don't necessarily have to write that from scratch. I can use products like API Gateway that allow me to get that stuff pretty much built in. But if you're dealing with APIs that are offered up by AWS, there's already a very strong foundation of security built around that, whether it's as simple as using access keys and secret keys, or if you're operating within AWS, typically you're dealing with something called roles, the AWS roles. And that actually gets you a dynamic authentication token that they refresh and handle under the hood, so you don't have to worry about it. So I can just say that, I've got this application and it has these permissions and it will handle the details of that under the hood. It's really seamless.
Awesome. Thank you, Michael. I hope that answered your question. Feel free if you have any more. Dustin will be in the chat box too, so you can continue that there. Awesome. Well, thank you so much, Dustin. Great presentation. Thanks for joining us today.
Yeah, thanks, Courtney.